All right, today we're jumping into something absolutely key to making AI actually smart: memory. How do we take an AI agent that's basically got total amnesia and turn it into something that can actually remember you, learn from you, and make your life easier? Let's get into it. So, have you ever had this happen? You're having a great chat with an AI, maybe a chatbot, and then you refresh the page or start a new session, and poof, it's like you've never met. It has no idea who you are. That's because, most AI models just don't have a way to hold on to memories. And if they're ever going to become truly intelligent agents, that's got to change. I mean, look at this. The difference is it's night and day, right? On one side, you have an AI without memory, and it's just stuck. It can't remember the simplest thing. But on the other side, an AI with memory, it can build on everything you've talked about before. This creates a really personalized, actually useful experience. And honestly, this is the absolute foundation for building smart AI agents. So, how do we make this happen? Well, it turns out AI agents really rely on two different kinds of memory. They work together to help the AI understand you and the world around it. Let's break down what they are. Okay, so first up, we've got short-term memory. The easiest way to think about this is like the AI's RAM, right? It's its working memory for the here and now. So let's say you ask it to plan a budget-friendly trip to Kerala. A minute later, you can say, now find some good hotels there, and it knows exactly what there means. It's keeping track of the immediate conversation. But here's the catch. It's temporary. As soon as the session ends, that memory gets wiped clean. Now, long-term memory, this is where things get really powerful. This is basically the AI's permanent knowledge base. If you tell it one day, hey, just so you know, I'm a vegetarian, it can actually store that fact away. Then, weeks later, you might ask for some restaurant ideas, and boom, it'll remember your preference without you having to say a word. And the secret to building this? Well, it comes down to a special kind of database. And that special technology is called a vector database. You're going to hear this term a lot. This is the engine that really powers an AI agent's long-term memory. It's what lets it store and, more importantly, retrieve information based on meaning, not just keywords. Okay, so to really get how vector databases work, you have to understand this one core idea: vector embeddings. It's pretty simple, actually. An AI doesn't see words like we do. It sees numbers. Embeddings are just the process of translating our language, words, sentences, whole documents, into a numerical format. We call this format a vector. It's something a computer can actually understand and do math with. So let's take a really simple sentence, like this one. AI is transforming healthcare, right? To you and me, that's just a few words. But for an AI, this is about to become a set of coordinates in a huge multi-dimensional space of ideas. And this is what the AI actually sees. That sentence gets turned into a vector, which is just a big list of numbers. Now, what's so cool about this is that sentences with similar meanings, like, say, machine learning is revolutionizing medicine, will end up with vectors that are mathematically super close to this one. This lets the AI search for concepts and ideas, not just a perfect word-for-word match. Okay, so here's how it all comes together in practice. When you ask the AI a question, your input, your words, are first turned into one of these vectors. Then the system zips over to the vector database and looks for memories that have really similar vectors. It pulls out those relevant memories and hands them over to the large language model, along with your original question. This gives the LLM all the context it needs to give you a really smart, memory-informed answer. It's a pretty elegant flow. All right, that's enough theory for now. Let's get our hands dirty and see how this actually works. We're going to build a really simple memory system for an AI agent, and we'll use two super popular tools to do it: LangChain, which is a great framework for this stuff, and Chroma, a local vector database that's just perfect for getting started. First things first, we've got to install our tools. It's just one line in your terminal. This pip install command grabs everything we need: LangChain to give us the structure, OpenAI's library to create our vector embeddings, and ChromaDB to act as our local memory bank. Okay, next up, in our actual code, we import the pieces we need. We're initializing the OpenAI embeddings model. That's the magic wand that's going to turn our text into those number vectors. Then we create our Chroma vector database. You can think of this line of code as literally creating the brain where our agent's memories are going to live. And now, for the fun part, it's time to actually teach our agent something. We use this add texts method to store a few simple facts as memories. Here, we're just telling it 3 key things about a user named Mohini. Behind the scenes, each one of these sentences is being converted into a vector and stored nice and neatly in our Chroma database. And here it is. This is the magic moment. We're now going to query our agent's memory. We ask a simple question in plain English. What food does Mohini like? Now, the system takes our question, turns it into a vector, and then does what's called a similarity search. It's looking for the memory vector that's mathematically closest, and therefore the most relevant to our question vector.
So we've built the brain, we've given it memories, and we've asked a question. The big reveal: what did our little agent manage to pull from its brand new long-term memory?
And there you have it. Mohini likes vegetarian food. The agent pulled the exact most relevant fact from its memory. Notice it didn't give us the other facts about her job or what she's learning, because those ideas, those vectors, weren't semantically related to our question about food. This just brilliantly shows you how powerful and precise this whole approach really is. Now, we used Chroma for our demo, and it's awesome for getting started and for local projects. But if you were building a huge production-level application, you'd probably look at a cloud solution like Pinecone. It's designed for massive scale and speed. But it's important to remember, this isn't a silver bullet. Vector search is powerful, but it can sometimes struggle with tricky stuff, like negation, for example. Mohini does not like spicy food. And when you're dealing with billions of memories, finding that perfect match becomes a really, really tough engineering challenge. Okay, so moving beyond our little demo, how is this technology actually being used out there in the real world? Because this isn't just some lab experiment. It's already powering major applications that you might even use every day. I mean, just think about it. Imagine a customer support bot that actually remembers your entire history with the company, so you never have to repeat your order number again. Or what about a personal assistant that doesn't just know you like sci-fi movies, but remembers you didn't like the last one it recommended, so it suggests something different? Companies are using this to build incredible internal search engines for their documents, and researchers are making agents that can read and synthesize hundreds of papers. Memory is the absolute key to all of it. So, let's just quickly recap the big takeaways here. First, memory is what turns a generic AI tool into a truly personal, context-aware partner. Second, AI uses both short-term memory for the current chat and long-term memory, powered by these vector databases, for lasting knowledge. And maybe most importantly, as you just saw, you can actually start building this powerful feature yourself with just a handful of lines of code. So, we've given our AI the ability to remember the past. But that just opens up an even bigger, more exciting question. What happens when an AI can not only recall its memories, but actually use them to reason, to plan, and to take action on really complex goals? Well, that's the next frontier for AI agents.
Thanks for watching. Hope you liked my video. If you have any specific topic which needs to be covered, please put it in comments box.